Now let's consider the following problem. A dietitian at a hospital wants a patient to have a meal that has 65 grams of protein, 78 grams of carbohydrates, and 122.5 milligrams of vitamin A. The hospital food service tells the dietitian that the dinner for today is salmon steak and baked eggs and acorn squash. Each serving of salmon steak has 30 grams of protein, 20 grams of carbohydrates, and 1 milligram of vitamin A. Each serving of baked eggs contains 10 grams of protein, 3 grams of carbohydrates, and 20 grams of vitamin A. Each serving of acorn squash contains 2 grams of protein, 15 grams of carbohydrates, and 32 grams of vitamin A. How many servings of each food the dietitian provide for the patient? Okay, so to solve this, we know that we have so many unknowns, right? But we would start by looking at the question. So the question is, how many servings of each food the dietitian provide for the patient? So that means we want to know how many servings of salmon steak, baked eggs, and acorn squash to meet the requirements. Hence, we will start by letting x be the number of servings for the salmon steak. And then we will let y be the number of servings. This is the number of servings for baked eggs. And z, that's the number of servings for the acorn squash. Now, let's set up the equations to help us solve our problem. So we can do that by creating a table. So let's create the table for x. So let's look at the number of protein for each serving of your salmon steak. So this is x salmon steak, that's x number of servings, y number of servings for baked eggs, and z is for the number of servings of acorn squash. And then let's look at the number of, or the amount of protein, carbohydrates, and then vitamin A. So let's look at the given here. So each serving, so it says here, each serving of salmon steak has 30 grams of protein. So each serving has 30 grams of protein. So that is per serving. So if you have x servings, therefore you have 30x grams of protein and 20 grams of carbohydrates per serving. So 20 times x, because x is the number of servings. And 1 milligram of vitamin A per serving. So 1 times the number of servings, x. And we do that same thing for the baked eggs. For baked eggs, each serving of baked eggs contains 10 grams of protein. So 10 grams of protein, 10 times the number of servings. So a total of 10y grams of proteins for the baked eggs, and 3 grams of carbohydrates, so 3 times y, 25 grams of vitamin A, 25 times the number of servings. That's the total amount of vitamin A for the salmon steak. This is for y servings. Now for z servings of acorn squash, we can get the total amount of protein. So now it says here each serving of acorn squash contained 2 grams of protein. So that means 2, that's per serving, times the number of servings, so 2Z. And then 15 grams of carbohydrates. So 15 per serving times the number of servings. So Z is the number of servings. And 32 milligrams of vitamin A. 32 times Z. Now, to write the equation, we can actually use this information here. So notice that at a hospital, a dietitian at the hospital wants a patient to have a meal that is 61 grams of protein. So that means we're just going to, if the meal consists of salmon steak, baked eggs, and acorn squash, therefore, to compute for the number of portions that they're gonna meet to meet the requirements, we're just going to add this. So that means adding everything here should give you a total of 61 grams of protein. So that's 61 grams. And then for carbohydrates, you add all the carbohydrates, depending on the number of servings of baked eggs, salmon steak, and acorn squash. Each should give you 78 grams of carbohydrates. And for vitamin A, if you add everything, it should give you 122.5 milligrams of vitamin A. So now, this would be the system of equations that we're going to use to solve the problem. So to solve this, we are going to use Gaussian elimination method to solve our problem. So now let's begin by writing the equivalent augmented matrix to the system. So we will write it here because we would need a lot of space. So the augmented system or matrix will be this 30. So let's just collect our first column will be the coefficients of x. So 30, 20, and 1. And then 1. Then we have 10, 3, 25, 2, 15, 32, then the constants, 61, 78, 122.5. Now, our goal is to get the reduced raw echelon form of the matrix. So our goal is to have all 1 on the main diagonal, and the lower part of the matrix will all just be 0. So entries in the lower half of the matrix will just be zeros. So to start, we can just interchange row 3. We're going to interchange row 1 and row 3 because row 3 already has 1 on the first entry here. So let's just interchange that. So we have 1, 25, 32, 122.5, and then you have 23, 15, 78, then you have 30, 10 to 61. So next is that we want this to be 0. We want the first column, third row entry to be equal to 0. So to obtain that, we will have to replace our third row by, you would multiply the first row by negative 30. So you just multiply the first row by negative 30 and then add that to the third row. So negative 30 R1 plus R3. Then you obtain the matrix here. So copy row 1, 25, 32, 122.5. Then copy row 2, 23, 15, 78. Now replace R3 by this. So you multiply 30, negative 30 times 1 is negative 30. Add that to 30, that's just 0. And then plug this into your calculator. Negative 30 times 25 plus 10. That should give you 740. And then next you have negative 30, R1, so that's negative 30 times 32, add plus 2. That is equal to 958. And then negative 30 times 122.5 plus 61. That is equal to 3,614. Next, we want this to be 0. We want the second term, or this term here, to be 0. Oh, hold on. Those are negatives when you plug this into your calculator. Now, next is we are going to, so let me just write down the steps. So for the third step, we are going to replace here, we want this to be 0. So row 2 first column to be 0. So we will replace, to obtain that, we will replace row 2 by negative 20 R1 plus R2. Negative 20 R1 plus R2. Then you would have, you copy the first row, 32, 122.5, and also the third row. Let's copy 0, negative 740, negative 958, and negative 3614. And then the second row will be replaced by this. You multiply R1, so you multiply this by negative 20 and then add that to R2. You get 0. And then negative 20 times 25 plus 3 is equal to negative 497. You plug into your calculator. Negative 20 times 32 plus 15 is equal to negative 625. And then negative 20 times 122.5 plus 78 is equal to negative 2372. All right, then our next goal is to have this second row, second column, we want to obtain 1 for that. So how do we obtain that? We can obtain that, we can make this equal to 1 by replacing R2. Let's just do it here because I don't have much space. So my R2 will be replaced by negative 1. So you multiply this by negative 1 over 497, or 1 over negative 497 times R2. So in other words, you just divide everything by negative 497 to make this term here positive 1. So you have 1, 25, 32, and then 122.5. Then here you will have 0, that becomes 1. And then now 1 over negative 497 times negative 625 is just equal to 625 over 497. And then negative 1497 times 2372 is 2372 over 497. Then you copy the last row. Negative 0, negative 740, and then negative 958, negative 3614. Okay, now we want this to be 0. So how do we obtain that? So for R3, we will replace R3 by, again, the goal is to make this equal to 0. So you obtain that by multiplying 740. So you can easily do that by multiplying 740 to this, that means to the second row. And then you add that to the third row. And then you add it to row 3. And then you obtain this matrix here. So you copy 1, 25, 32, 122.5. And then you have 0, 1, 6, 2, 5 over 497. And then 2, 3, 7, 2 over 497. Then if you perform this operation again, you have 740 times 1 is positive 740 minus 740, that is 0. So 0, that's what we want to get. So you have 740 times, you just multiply this, 740 times this expression here minus 958. Do that on your calculator, and this is what you would get. 13626 all over 497. And then here you will do that same thing. You will multiply whatever. You use the fraction. I want you to get the exact answer. So it will be 2372 over 497. You multiply that by 740. And then you subtract it. So multiply that by 740 and then you subtract it by 3614. Get the exact number. Okay, so this is the new matrix. Looks intimidating, but now we have here like a reduced row echelon form. You want this part here, the third column, third row to be equal to 1. And to do that, you will have to multiply both sides, or divide both sides by the expression here. Okay, you divide both sides by the expression here. Or in other words, you can have that z will be the expression here, the entire expression here. That's 2372 over 497 times 740, whatever the value you got, minus 3614. If you try and plug this into your calculator and divide it by the whole thing, 13626 over 497. Okay, so when you plug that into your calculator, you will get z to be equal to 3. So you have z equal to 3. So now you have z equal to 3, then you solve for y. To solve for y, you use this equation here. You have y plus 625,497 times z is equal to 2372 over 497. And then you plug in the value for z here. So you plug in the value for z, replace z here by 3. So you have y. And then you move that to the other side of the equation. Since I don't have that much space, let me see. So on your calculator, you will have to plug in 2372 over 497 minus this expression and then replace z by 3. So it's 625 times 3 over 497. And then you can verify that y is just equal to 1. when you have y equals 1. Then the next part is you would use the first equation here. So the first row, this first row here indicates that x plus 25y plus 32z is equal to 122.5. Then to solve for x, you will have to replace the y here by 1, so that's 25, and then plus 32 times your z is 3 is equal to 122.5. Then you can multiply 32 times 3 plus 25. That gives you 121. So it gives you 121. So from here, you have x plus 121, and that is equal to 122.5. So therefore, from there, x is just equal to 1.5. So that means x is equal to 1.5. So that means you need 1.5 servings of salmon steak, 1 serving of baked eggs, and 3 servings of acorn squash. If you do that, you will meet the requirements that the dietitian wants the patient to have a meal for that. All right, so I'll just skip number 26. You can do this. So the good thing here is that the table is already given. You just need to set up your system of equation and then use the Gaussian elimination method to solve the word problem. Okay, so number 27. Write the second term of the sequence. So we are given here the recursive formula. A sub 1 is given. You are asked to find the second term. So to do that, you just have to plug this into the equation here. What you want is a sub 2. That's the second term. And if n is equal to 2, you will have 2 minus 1. So that's a sub 1. So you have 2. 2 minus 1 is 1 plus 1. Now, a sub 1 is given to be 5. So you have 2 times 5 plus 1. 2 times 5 is 10. Plus 1, that is equal to 11. So the second term of the sequence is equal to 11. Next, we are given here a sequence that is defined using a recursion formula. We are to write the first 4 terms of the sequence. Now, this a sub 1 is given to be 8, and then a sub n is equal to a sub n minus 1 plus 2 for all n greater than or equal to 2. All right, so a sub 1 is already given. That is equal to 8. So just copy 8. Now a sub 2, that means you replace n here by 2. So you will have a sub 1, that is just a sub 1 because it's 2 minus 1, that is equal to 1, plus 2. But what is a sub 1? 8. So that's 8 plus 2, and that is equal to 10. Now for a sub 3, that means replace n by 3. So a sub 3 is equal to 3. A sub 3 minus 1. 3 minus 1 is 2. So that means it's a sub 2 plus 2. And what is a sub 2? A sub 2 is 10. Plus 2 is 12. Now, a sub 4 is just equal to a sub 3 plus 2. 4 minus 1 is 3. So that's why you have 3 here. And then plus 2. But what is a sub 3? That is equal to 12. Plus 2 is 14. So these are the first 4 terms of the sequence. Now for the next example here, we are given the general nth term of the sequence. we are to write the second term of the sequence. So that means that n is just equal to 2. So you plug in 2 for n, and then you solve for the equation. So let's go ahead and do that. Again, we want a sub 2. That's the second term of the sequence. This is equal to -1. N is 2. 2 plus 1 all over 2 squared minus 1. So this is -1 cubed. 3. 2 plus 1 is 3 over 2 squared. That's 4 minus 1 is 3. So that's 4 minus 1. 4 minus 1, it's 3. Now, -1 cubed is equal to -1. 4 minus 1 is 3. So the answer is -1/3. Okay, so for the next number, we are to write the first 4 terms of the sequence, and the general term is given. You can just replace n here by the value of n here. So if it's a sub 1, that means n is equal to 1. So evaluate the expression here at n equals 1. Here, evaluate this at n equals 2. For a sub 3, evaluate the expression here when n is 3. And for a sub 4, the fourth term, that is when n is equal to 4. And here it's the same thing. You get the first 4 terms of the sequence given the general term of the sequence. I'll go ahead and show you how to do this. So if it's a sub 1, that means n is equal to 1. So that means you're going to evaluate -1, 1 plus 1, so that's squared, all over 1. So 2 to the first power is just 2, plus 1 is 3. So 2 to the 1 plus 1. Now, if you have -1 raised to an even power, that means positive. So +1 over 1 plus 3 plus 2 plus 1 is 3. So the first term is 1/3. Now for the second term, we have -1 raised to, so that is when n here, that is when n is equal to 2. When n is equal to 2, you have 2 plus 1, that is 3. So 3 all over 2 squared plus 1. This is equal to -1. If the power is odd, it's -1. So -1 over 2 squared is 4, plus 1 is 5. For the third term, you have -1 to the n. This is when n is equal to 3. So 3 plus 1 is 4, all over 2 cubed plus 1. If the power is even, that means positive. +1 over 2 cubed is 8, plus 1 is 9. Lastly, this is when n is equal to 4. When n is equal to 4, you have -1 to the n is 4th. So 4 plus 1 is to the 5th power, all over 2 to the 4th plus 1. So if the power is odd, -1 raised to an odd power is -1. All over 2 to the 4th is equal to 16. So that is 16 plus 1, 17. These are the 4 terms, or the first 4 terms of the sequence. So for the next item here, we are to find the sum. Now, to do this, we would need to expand the given expression. So we are to write this as, so what does that mean? This means that you're going to add this of the form here, starting at I equals 1. So let's plug in I equals 1. So you have 1 times 1 plus 2. So we're just expanding it. This sigma notation here means summation. So plus the second term. That is when I is equal to 2. So that's 2 plus 2. Next is when I is equal to 3. That is 3 times 3 plus 2. And then next is when I is equal to 4. And we stop there because our upper limit of summation is just equal to 4. So you have 4 times 4 plus 2. And then you simplify. So this is 1 plus 2 is 3 times 1 is 3. This is 4 plus 4 times 2 is 8 plus 5 times 3 is 15 plus 6 times 4 is 24. Then you add them. So if you add them up, this is just equal to 50. So for the next item, we are to find the sum of 3. I runs from 4 to 9. So summing this up, take note that your I here, the lower limit of summation, begins at 4. So I is from 4, starting at 4, up to 9. So when we expand this is just adding 3 to itself. How many times? So 4, this is 5, 6, 7, 8, so adding 3, 9. So you're just adding 3 to itself 6 times. 1, 2, 3, 4, 5, 6. So that is starting at 4 up to 9. So 4, 5, 6, 7, 8, 9. So in other words, we added 3 to itself. Again, how many times? 6 times. So that's just 3 times 6. And that's equal to 18. So next, we are asked to express the sum using summation notation. So you just look at the pattern here. Note that 3 is constant, so the power is constant. And what is changing is the base. So it starts at 1 and ends at 10. So that means that this is just equal to, you have a counter of I here. So you're going to use I to the third power. I runs from 1, so that is when I cube, up to 10. Okay, so that's the summation notation. Now another one, we are to express this sum here using summation notation. Use 1 as the lower limit of summation and I for the index of summation. So to do this, you just look at what is constant and you write that as the number and what is also changing. Now here, notice that 6 is constant and the denominator here is changing. You could think of 6 as 6 over 1. So with that, we can just write this as 6 raised to I. I is our limit of summation and the denominator is also I. I starts at 1. So when I is equal to 1, you have 6 to the first power over 1, that's just 6. And then 6, when I is equal to 2, 6 to the second power over 2. Then it will end at I equals n. So the upper limit of summation is n. So you get 6 to the n over n. So this is the summation notation for the expression given here. So lastly, we have this. We are again to express the sum here using the summation notation. And use 1 as the lower limit of summation. So if you consider this, it is actually changing. So it's 2, and then 6 to 10. But note that here, you are actually given the general form for the nth term of the expression. So the expression here will just be the nth term here. And then you just check, right? So we would suspect that the expression here will just be 4n minus 2. And then your low index of summation, it says here I. So in that case, the n will be replaced by I. So I, and it starts at 1. So I equals 1 and ends at n. So it ends at n here. And then you can double check. So when I is equal to 1, you will have 4 minus 2, and that is equal to 2. When I is equal to 2, you have 4 times 2, which is 8, minus 2, and you should get 6. So, therefore, we know we are correct. And the last term with that is when I is equal to n will just be 4n minus 2. So that concludes the review. I hope you do well on your test.